Okay, good. Yay. All right, so we'll try it. Okay, so the first one is an example of the sum rule on that first page. And so what the sum rule says is if I have the limit of a combined set of functions, I can just split that up and find the limit as x approaches 3 from the right of f plus the limit as x approaches 3 from the right of g. So I can split it up and find each one. So I look at my graph to find the first part. For f, I'm going to approach x equals 3 from the right. As I approach 3 from the right, the y value is 6 plus 3 from the right for g. So then I need to look at the g graph. And if I approach 3 from the right on the g graph, looks like I get 8. 3 from the right, 8. And so 6 plus 8 is 14. So are you guys okay with that one?
Yep.
Okay. So then on part B, it's similar, but now I have this 3 in front of the f of x. So that is a combination of the coefficient rule, which is rule number 3, the coefficient rule, and this time the difference rule. And difference rule is rule number 4, or property number 4. So what that'll look like, I can split it up into 2 separate limits. The limit as x approaches 5 of f of x, but that 3, I'm going to multiply it on the outside. So 3 times the limit as x approaches 5 of f of x. Because that's what the coefficient rule says. I can move this 3 to the front. Minus 2 times the limit as x approaches 5 of g of x. And then I'll look at each one of these. This 3, nothing happens with that 3. I just bring it down. And then for the limit as x approaches 5 of f, I'll go to my graph of f. As x approaches 5, the y's approach 2 minus 2. And then the limit as x approaches 5 on the g function, the y's approach 4. So that would be 3 times 2 minus 2 times 4. 6 minus 8, negative 2. You all want to try the, try C. Try part C. Okay, so I ended up getting negative 1. So, because you'll do the limit as x approaches negative 5 from the left of f minus the limit as x approaches negative 5 from the left of g. For f, approach negative 5 from the left side, and I've got 3 minus for g, negative 5 from the left side, ended up at 4, and 3 minus 4 is not negative 4. 3 minus 4 is negative 1. So far, so good?
Yep.
With part D, that's a combination of the coefficient and the quotient rule. And I can still split it up. So I can still say that this is equal to 3 times the limit as x approaches -7 of f divided by the limit as x approaches -7 of g. The quotient rule says I can split them up like that. Limit of a quotient is the quotient of the two limits. I need to erase all these extra marks here. So then on the graph of f, the limit as x approaches -7, I'm getting 4 or 5. Negative, oh, that's -6.
That's
There we go. 5. So 3 times 5. And then on g, as x approaches -7, the y values get close to 3. And 3 times 5 divided by 3, 15. Check.
I still don't understand how you get spot.
yeah. Hold on.
How I got what?
See,
C. Okay. Are you okay with splitting up the limits?
yeah.
Okay.
Well, I wrote it out the right way.
Okay.
I just don't know how you got 3 and negative.
So let me highlight it. Okay, so for this part, on F, I'm going to approach -5 from the left. I'm going to erase this. So -5 is that X value right there. If I approach -5 from the left side, I end up at 3. So that's how I got the highlighted pink part to be 3. And then for this part, on G, I need to also label this G. On G, the limit as x approaches -5 from the left. -5 is right here. If I approach -5 from the left, I get really close to that open circle, which has a y value of 4. And so 3 minus 4 is the -1. Bailey.
On D, wouldn't it just be 5?
Yeah. That's right.
I cannot 3. That's 15. Yes, you are correct. I am not. Let's change that math. 3 times 5 is 15. 15 divided by 3 is 5. Thank you, guys. Anything else? All right. Then let me let you guys try. On the rest of this page, these examples are still kind of pretty straightforward. Like when I say straightforward, I mean you'll kind of, the limit property is a little intuitive. Like it's set up, you're like, okay, yeah, sure, it makes sense that I would do that. So try all of them except for K. And then when we get to compositions, sometimes it can be a little different. We'll do K together. Give those a shot. Okay, so let's start off. I'll tell you the answers, and then we can work out what we want to work out. All right, so on E, I ended up getting D and E. On F, I got 36. On G, I got 2 square root of 10. If you don't simplify it, it would be the square root of 40. But I would prefer the 2 square root of 10. H I got does not exist. And then J, I got 0. So how did it go?
Good.
Are there any of these you want to work out?
I want everything
But G, okay. So let's talk about G. G is a combination of that coefficient rule and the square root rule. So the root rule, that's rule number 9 on the front page. And it says if I'm going to take the limit of the square root, then I can pull the square root up to the front. Whatever I get the limit to be, take the square to the front. And then that coefficient rule, I'm going to multiply the limit as x approaches 4, g of x times 8. So if I write it out, here's what it'll look like. This is equal to the square root of 8 times the limit as x approaches 4 of g of x. So then that means I'm taking the square root of 8, and then I'll go to g to find the limit. G as x approaches 4, the y values approach 4. Y's approach 5. Right here, I'm looking at that point right there. So 5, which means I pretty much have the square root of 8 times 5, which is the square root of 40. And that's how I get 2 squared root of 10. Yes, Landon.
Why was E does not exist?
Why was E does not exist? Okay, so E, I've got 4 times F times G, which means I can do this 4 on the outside means the whole thing would be multiplied by 4. So I could say 4 times the limit as x approaches 3 of F times 4 times the limit as x approaches 3 of G. So the 4 I'm not going to do anything with yet. I'll just bring it down. The limit as x approaches 3 on F. I look at that graph. As x approaches 3, the y value looks like it's approaching 6. So I get a 6 right here. Times, bring down the second 4. And then on G, I have to approach 3 again. And as x approaches 3 on G, on the left side of 3, the graph goes up to infinity. Negative 3? What am I approaching? Positive 3 or negative 3? Approaching positive. Okay. On the left side of 3, the y gets to positive 1. On the right side of 3, the y's approach 8. And so 1 and 8 are not the same number. So that part does not exist. When you multiply 4 times 6 times 4 times does not exist, we'll get does not exist. Anything else you guys want to see worked out? Okay, let's talk about, before we talk about compositions, there's also one that's going to pop up, and I'm going to erase these marks over here. Because it's not listed as one of the properties, but it does pop up on your assignment. If you've got room somewhere on the page, let's make up a new problem. Let's do the limit as x approaches 2 of x minus 1. No, not x minus 1. F of x minus 1. So we're not subtracting one outside, we're subtracting one inside the parentheses. So what this is saying, this is the graph of f. They're asking me about the graph of x minus 1. And if you remember your transformations from way back in Algebra 2, f of x minus 1 means that the graph would be shifted to the right 1 unit. So you would imagine this whole graph shifting to the right 1 unit, and then the limit as x approaches 2 of the new graph.
If it would have been alpha, I would have been down 1.
Yes. But, man, like trying to keep track of all that in your head, like what would this look like if I shift it over? And then what's the limit of the new graph? Can be kind of tricky. Or maybe I don't necessarily want to just redraw all of this. So there's an algebra way that we can do this. I can take this 2, subtract 1 from it, and then this would be equal to the limit as x approaches, what's 2 minus 1? 1 of just f of x. So use the graph I have to find the limit as x approaches 1, which would be negative 2 here. So we'll do another one. The limit as x approaches, we might have to estimate here. Limit as x approaches 5 of f of x plus 2. This is the same as the limit as x approaches, take the 5, add 2, x approaches 7 of that graph. So as x approaches 7, what would the limit be? It's continuous, so I would continue this graph.
Negative 2.
Negative 2. So you'll see a couple of problems like that. Is that okay? All right. Let's talk about compositions. So on the first page, you have, I think it's property 8. Talks about composite functions. So property 8, that's the composite function rule. This notation, limit as x approaches c of, you say f of g of x. That means you're putting one function inside the other. So that's the same as f of the limit as x approaches c of g of x. So sometimes you'll think this whole thing doesn't exist, but it actually does. And so there's a note here. We need to add a little special note here. If you see, I don't need a comma. If you find that the limit as x approaches c of the g of x part does not exist, the whole limit of the composition function can still exist. And the way that we would find it, we would check the left-hand limit and the right-hand limit. So we will need to check left and right-hand limit. Sometimes they'll exist, sometimes you'll be in this scenario, but just because you run into D&E on the composition doesn't mean the whole thing doesn't exist. So let's look at example K. And then we're going to look at, and I think I actually want to copy and paste that graph right next to it. No, I don't. We'll just do it this way. All right, example K. So I've got the limit as x approaches negative 2 of f of g of x. That's the same thing as f of the limit as x approaches negative 2 of g of x.
What is the F?
I'll show you.
Oh,
Just a
okay.
second. So I'm going to highlight this part, and I'll show you what we do with that number. So find the limit as x approaches negative 2 of g. So look at the graph of g. What's the limit as x approaches negative 2 on g? What's it looking like? As x approaches negative 2 on g, I get negative 3. I get negative 3. Okay. So then that means I now have f of 3. And the 3 I got from finding that limit. So then go on f. And what's
Then
f of
find
3?
3, which is 6.
6. Or negative, is it 6 or negative 6?
Positive 6.
Positive 6. Wait, did I get positive 3 or negative 3? I wrote down a negative here.
You wrote down negative, it should be negative 3, so then it would be
Yeah, as x approaches negative 2, the y values approach negative 3.
yeah, and then it would
So
be
this should
negative
be-
6.3.
Negative 3. And so then on f, at negative 3,
Negative 6.2.
1, 2, 3, the y value is negative 6. So negative 6 is my answer. So far, so good? Okay, so let's find another composition. Skip to the next page where you have A and B. All right, so A of the limit as x approaches 3 of f of g of x. So then I'm going to find that's equal to f of the limit as x approaches 3 of g. So let's find this part. So on g, as x approaches 3, the y values approach 1. So that means I need to find f of 1. F of 1. And f of 1 equals
Negative 2.
negative 2. Try part B and D. And on one of these, you'll have to extend the graph of G. So you can extend it following the slope to find your number. And try B and D.
I have no idea. You ever just find random stuff in bags?
Do I ever just find money? Never. I wish. All right, so for B, I'll be finding G of the limit as x approaches negative 1 of f. So I need to look at f first. When x is approaching negative 1, the y values
-6.
negative 6. So that means I need to find g of negative 6. And my graph of g doesn't quite extend to negative 6. But I can also see this, I could extend this graph to get to negative 6. And the slope of that graph is 2. So if I extend that slope to 2, there would be so there's a point on the graph here at negative 4, negative 3. If I go down 2 and to the left 1, there's a point at negative 5, negative 5. And then go down 2 and back 1 again. That's where you'll find negative 6. Negative 6, negative 7. So g of negative 6 is negative 7. For part D, that's the same as g of the limit as x approaches negative 3
That's negative.
of f of x, which means I'll be finding g of, what's the limit as x approaches negative 3 on f?
Negative 6.
Negative 6. Hey, and I already know what g of negative 6 is.
Negative 7.
Negative 7. Now let's take a look at what happens in part C. This is the special one. So I'm going to try to find f of the limit as x approaches 1 of g of x. What's the limit as x approaches 1 of g of x?
Doesn't exist.
This part does not exist. And since that part doesn't exist, I need to check the left and right hand limits. So that means I'm going to need 2 more things down here. And I'll zoom in so I can write it out larger. And see if they're the same. So I'm going to need to find f of the limit as x approaches 1 from the left of g of x. And then I'll also need to find f of the limit as x approaches 1 from the right of g of x. And Emery, I think I heard you ask
Yeah,
me.
no,
John.
I got it.
You got it? Okay. I didn't realize you asked that until about 1 minute later. So we'll check from the left and from the right. And so the overall composition can exist as long as these 2 numbers are the same. Now we're going to see. From the left, if you approach 1 from the left, what did you get on G? I approach 1 from the left. I'm not there yet. I'm getting negative 1. Are you guys getting negative 1? Okay, so now, what's f of negative 1? Negative 6. Looking at that graph. Okay? And then, for the second part, I'm going to find f of, now I need to find the limit as x approaches 1 from the right.
Negative 3.
Negative 3. And what's f of negative 3?
Negative 6.
Negative 6. Are these numbers the same?
Yes.
Yes. So negative 6. These are the same. So, how do I write that? The limit as x approaches 1 of f of g of x equals negative 6. Just be aware, if you have a D&E and its composition, check the left and right side first.